The instructions here say express as a sine or cosine function squared. We have the expression 1 plus cosine x all over 8. So we have cosine raised to the first power. We want this entire expression to be written as a sine or cosine function squared. What we're going to think about right now is the power reducing formula for cosine squared theta. Cosine squared theta is equal to 1 plus cosine of 2 theta all over 2. And this comes from the double angle identity for cosine, just rewritten. All right, so the expression we have is similar to the right side of this equation here. So we need to rewrite our expression in a way where we can use this power reducing formula in reverse. So the first thing I'm going to focus on is the denominator. So our denominator is 8. The denominator over here in the formula is 2. So I'm going to rewrite 8 as 4 times 2. But what I'm going to do is bring that 4, which is in the denominator, out. So I'm going to express that as 1/4 times 1 plus cosine of x all over 2. So this is an equivalent expression. Again, just rewriting 8 as 4 times 2. So now I have 1 plus cosine x over 2. My power reducing formula is 1 plus cosine 2 theta over 2. So inside my cosine function, I simply have 1x. I need 2 times a function of, in this case, x. So how can I rewrite x so that it's 2 times something? Right, so let's go ahead and try that. I have that 1/4 in the front still. I have 1 plus cosine of 2 times. So basically I'm thinking, how do I rewrite 1x as 2 times some expression involving x? Well, that's going to be 2 times x over 2, right? So 2 divided by 2 is 1, so this is equivalent to just 1x right here. But now it has this form of 2 times a variable expression. So x over 2 is in the place of theta in my formula. So now, and this is still all over 2, so now what I can do is I can say this 1 plus cosine of 2 times x over 2 all over 2, that condenses down to cosine squared of, instead of theta, what's in place of theta, x over 2. So cosine squared x over 2, and then I can't forget about that 1/4 in the front. So now I have rewritten my original expression as a cosine function squared. Now we have the expression 1 minus cosine of x over 2 that we want to write as a sine or cosine function squared. So this time we're going to use the power reducing identity for sine. Sine squared theta is equal to 1 minus cosine 2 theta all over 2. So why are we using the power reducing identity for sine this time? Well, because here the operation is subtraction. So I have 1 minus cosine of x over 2. On the last example, I had 1 plus. So that meant that I was going to use the cosine power reducing identity. All right, so now we have to try to get our expression to sort of look like the right side of this expression here. And notice that our expression isn't divisible by anything, really, besides 1. So we're going to start by taking this expression and dividing the entire thing by 2. So 1 minus cosine of x over 2 all over 2. But I can't just randomly divide by 2. I want this to be an equivalent expression. So if I divide by 2, I also have to multiply by 2. Because 2 divided by 2 is 1. So this is an equivalent expression. All right, so now I'm starting to look like what I have over here. But what I need inside the cosine function is, again, something that looks like 2 times and then a variable expression here. So how do I rewrite the inside of this so that it's 2 times something here? So I'll rewrite this as 2 times 1 minus cosine of 2 times, all right, what? So here we can do this by inspection. So here, what would I have to multiply 2 by to get back to x over 2? So that's just going to be x over 4. So if we think about that, 2 divided by 4 is 1/2. So I have this is 1/2 x. So we can do this sort of by inspection. The other thing that we can do, if you need to, is you can go ahead and say, I need the inside here, I need x over 2 to be equal to 2 theta. And then I need to solve for that theta. So I'm going to divide by 2 or multiply by 1/2, however you want to think about it, right? Multiply both sides by 1/2, so we get x over 4, the 2 and the 1/2, multiply to be 1. So I have theta equals x over 4. So that's another thing you could do, right? Set the inside of each equal to each other, x over 2 equal to 2 theta, and solve for theta to know what 2 needs to be multiplied by. So in any case, we find out that theta is equal to x over 4, so we can rewrite this piece 1 minus cosine of 2 times x over 4 all over 2 as sine squared of x over 4, and I will bring that 2 down in the front.